Hello everyone. Thank you for joining me today. My name is Lena. I am a doctor in human biology and I have a PhD in sports science. Let me start with 4 questions. Why do we lose energy? Why do we lose mind brightness? Why do we gain fat and struggle losing it? Why does our stress level increase and why do we sleep badly? All of us should know the answer to these questions before blindly following whatever program is proposed to us. Knowing these scientific bases will help you make conscious choices, because there are thousands of trends, but only one chemistry of the human body. Why do we lose energy and mind brightness, gain fat and struggle losing it, increase our stress level and sleep badly? These are consequences of a glycemic curve alteration, glycemic peaks and consequent insulin peaks. Glycemic curve measures the concentration of glucose in the blood over time. When we eat carbohydrates, then turn into glucose in the blood. Glucose, an essential molecule to life, reaches each cell to produce energy and to make the brain function. Glucose is so important that our body works to maintain its concentration in the blood within an ideal range. As we see in this slide, ideal fasting range is between 70 and 100 milligrams per deciliter. Otherwise, ideal level post-prandial range, 40 to 60 minutes after the meal, is within the range 70 and 140 mg per deciliter. Glucose can become harmful if its concentration in the blood is too high, above 140, or too low, below 70. 2 hormones, insulin and glucagon, play opposing roles in regulating blood sugar levels. Insulin facilitates glucose uptake into cells and helps lower blood sugar levels after meals. Conversely, glucagon stimulates glucose release from the liver when blood sugar levels drop too low. This delicate balance between these hormones is essential for maintaining metabolic balance. What happens when we eat a meal that is high in carbohydrates, low in protein and with a high glycemic index? Well, this produces an excessive concentration of glucose in the blood, resulting in a glycemic spike. Here you can see the graphical representation of a glycemic peak. As it is harmful to our health to have an excessive blood sugar level, the pancreas triggers hyperproduction of insulin. And let's look at the effects of an overproduction of insulin. Insulin stores glucose as glycogen in the liver, 100 grams, and muscles, 400 grams. Insulin turns the excess glucose into fat. And insulin blocks the demobilization of fat reserves. As long as insulin concentration is high in the blood, no fat is burned. An excessive amount of glucose is pushed into cells, causing oxidative stress. Insulin also causes a drop of glucose concentration in the blood, hypoglycemia. Let's look at the effects of hypoglycemia. Lack of energy, mind brightness reduction, sleepiness, foggy-mindedness around an hour after meals, hunger and sugar craving. Usually we crave for sugars and carbohydrates and the peak starts again. The effects of these excessive fluctuations of the glycemic curve can lead to energy dips, lack of shine, accumulation of fat, stress and disturbed sleep. Moreover, this cycle can also lead to oxidative stress. Nutritional strategies that follow a 40-30-30 ratio between macronutrients helps to keep the glycemic curve within an ideal range, where 40% of calories in your meal are coming from carbohydrates, 30% from protein and 30% from fat. Why do we lose energy and mind brightness? Why do we gain fat and struggle losing it? Increase our stress level and sleep badly? Because of a reduction of muscle efficiency and mitochondrial activity. Let's understand what mitochondria are and their importance in energy production. Our body is made up of approximately 30 billion of cells, and each of them contains hundreds or thousands of mitochondria. Majority of mitochondria is found in cells of muscles and liver. Mitochondria are the batteries of our cells. Glucose, thanks to insulin, gets into the cells and transported to mitochondria. Inside mitochondria, a series of biochemical reactions take place to produce ATP, a molecule that provides energy to the cells. Mitochondria can be damaged by reduced muscle efficiency caused by an insufficient intake of proteins and amino acids and lack of physical activity. Mitochondria can also be damaged by oxidative stress caused by repeated glycemic peaks. The waste products of ATP-producing reactions are highly reactive molecules known as free radicals. If these exceed our capacity to neutralize them, they can damage the mitochondria and the cells. Oxidative stress. The less efficient is the mitochondrial activity, the less is their efficiency in energy production, because mitochondria are also the kiln where fat gets burned. Hence, worse is their efficiency in absorption of glucose from the blood. Said that, it is crucial to know that correct protein and essential amino acid intake combined with daily physical activity helps to improve muscle health and the efficiency of mitochondria. In conclusion of my part of this session, we have answered to these 4 questions. Why do we lose energy? Why do we lose mind brightness? Why do we gain fat and struggle losing it? Why does our stress level increase and why do we sleep badly? Knowing this information will help you make the best decision for your well-being and to achieve optimal health. Thank you all very much for your attention.